Hey folks, Mr. Dell here. Hey, we are looking at a problem that has us determining what the function is given some values, some inputs and outputs. So this is a problem I'm taking from CPM, and this is Integrated Math 2, section 9.1.3, number 9-29. So it says, each of the following pictures shows how the same function, so we have the same function machine, changes the given x into a corresponding f of x value. So you have an input, and that gives you the output, right? So remember, your input is this one, and then these are your outputs on the ground here on the that come out of that function. Whatever we need to do to f it, whatever we do, we put a 10 in, do the math, and get the 99, right? So it wants to know, what is that equation? What is that function that is being used in each of these situations, right? So we put in a 2, out comes a 3. We put in a -3, out comes an 8. We put a 0 in, out comes a -1. So it's the same function. So we got to figure that out. So I tend to try to look to see, okay, is this linear, first of all, right? Linear being, can I, for example, from 2 to 3, can I, linear would be if I could just add 1, that would give me that. Well, is that the same case for each of these? If I just add 1, do I get -1? Well, no, can't be that. So it's not just that. So I just play this game of just trying different things. So maybe instead of just adding 1, maybe we multiply by 2. So we would say, so I'm gonna put some ideas here. I thought maybe x plus 1, and that wasn't it, right? So then what about if I multiply by 2? So if I take 2 times 2, I get 4. So I would have to then subtract 1 to get to the 3, right? So maybe what about 2x minus 1? So let's check that. So if I would check that here, 2 times -3 is -6, and then -1 would be -7, and it's not 8, so that's not it either, right? So if it works for one, it has to work for all of them. So I'm going to just keep trying things. Well, what if I multiply by 3? So times 3, so 3x. Well, if I multiply by 3, I get 6, and then to get to the 3, I got to subtract 3, so 6. So it'd be 3x minus 3. Well, let's check that one. Again, put it in here. So 3 times -3 is -9. And then -9 minus 3 would be -12. Again, it's not the 8, so it can't be that one either. So, all right. Now we're going to, maybe it's not linear, because if I look at this 10 and 99, actually, it may, that to get to 99 is a big leap, right? It's multiplying by 10. So I could say 10 times 10, and that would subtract 1 would give me 99. 100 minus 1, right? But if I multiply 2 times 10 and subtract 1, I'm not going to get to the 3. So, but to get to that, I think of this 10 times 10, I think, well, what other operation, what other thing do you do the x to get there? And so if 10 times 10 is the same thing as saying x squared. So let's test that. Maybe it's not linear, maybe it's quadratic. So if I square that, and then -1. Let's check this one. So 2 squared. So 2 times 2 is equal to 4, and then -1. Oh, that worked. So let's check this one. If I square this one, so multiply by itself, you get 9, and then subtract 1, you get 8. Test the last one. 0 squared minus 1 would be -1. So I believe that's our function. So there we go. So f of x is equal to x squared minus 1. So that's a process of just guess and check and playing with numbers until you come up with